Welcome to the notes for 1-7. Today we are going to talk about point-slope form of a line. In the past, you've talked about several other forms of linear equations, one being slope-intercept form, y equals mx plus b. Another one should have been standard form, ax plus by equals c. Okay, today you're going to learn about a third one, and it's not any more complicated. It's actually pretty basic, but there are some good situations where you can use it and it may make things easier. Okay, so let's get started. The first problem here is just a little warm-up. It says write an equation for the line that has a slope of 2 and passes through the point -1, 5. For this one, we're going to go ahead and use slope-intercept form. Right, we're going to write our equation in this form using the information we've been given. So we know right now that we have a slope of 2, and we have that point -1, 5. And remember, that's just an ordered pair, right? So we know that the x is -1 and the y is 5. And we're going to use this information, right, because we know that if we have an m, we can put our m in. If we know an x and a y, we can plug those in here, and that'll allow us to solve for the b value, which is the y-intercept. Let's go ahead and plug this information in and then figure out what the equation will be. So our y value is 5, our slope is 2, and our x value is -1. And since we have one variable left over here, we can now solve to figure out what that b value is. So 2 times -1 obviously is -2. All right, we'd add it to each side. We'd end up with 7 is equal to b, which means that our linear equation would be y is equal to 2x plus 7. So this is the line that has a slope of 2 and passes through that point -1, 5. All right, let's move on. This slide here says now to write an equation for the line that has a slope of -5/11 and passes through the point 0.8 comma pi. And these are messy for a reason. Hopefully we'll prove a point here before we're done. You'll understand why we're learning the point slope form. Okay, so if we were going to do the same thing here, right, we're still thinking about using y equals mx plus b. Right now we would have our slope is -5/11, and that point that we're going to use is the point 0.8 comma pi. So our y value is pi. We'll put that in. Our slope is -5/11. Our x value is 0.8. And then we have plus b. So as we go through and try to solve for the y-intercept, right, this is kind of hairy. We've got pi, we've got a fraction, and we've got a decimal. If we were to multiply 0.8 times -5/11, I believe that's like -0.36 repeating, which is just -4/11. So when we multiply these two together, and you can use your own calculator, you can trust me that I've multiplied it correctly on this one, right? But we get -4/11 plus b still equals pi. And we don't have a need to turn this into, 3.14 or anything like that there, okay? We're just going to keep it in its, exact form, which is pi. We'll isolate our b by adding 4/11 to each side. So we get this expression, pi plus 4/11 is equal to our y-intercept. That's the value of it. So if we were to go through and try to write out our linear equation now, right, we know it would be y equals our slope -5/11, okay, and then we'd have times x, and then we'd have plus, and we're just going to write this as pi plus 4/11. Okay, so it's kind of messy, right? So even with the messiness that we have at the beginning there, we can still use it use what we know from slope-intercept form to come up with the equation, but sometimes it's just a little bit more complicated, okay? And what we do know, though, is there is another form, or you are learning, there is another form that we can use that might make some of this work a little bit easier. And that is what we call the point-slope form. So point-slope form of a line, okay, it works really well when you have what two things? Well, when you have a point and a slope, okay? So point-slope form is called point-slope form because that's when it's most useful, when you have a point and a slope. Okay, so if you have, that m is still going to be your slope, so we're going to say given m is a slope, and we have a point, and we're going to call that point x sub 1 comma y sub 1. So it's just our one point that we have, okay? Here is what the formula kind of looks like. We're going to say y minus that y sub 1, okay, so y minus whatever that y coordinate is equal to our slope, why is it drawing on there, sorry, okay, our slope times, in parentheses, x minus, and then we have that x coordinate. Okay, so this is the formula for point-slope form, and we'll kind of derive it and look at where it comes from later on. You'll be surprised. You probably already will know where it came from, but you just got to make that connection. Okay, so we'll come back and we'll look at this a little bit more. Okay, but we're going to have a y minus y sub 1 equals m times the quantity of x minus x sub 1. And remember, when we go through and we do it here, right, this is a number, this is a number. So these will actually be numbers here. And then your input and output, right, are just still going to be this y and x. But you'll see here when we get a little deeper into it there how that all works. All right, so it says graph the line y equals 2x. Okay, let's do that first, right? So right now we know if we have y is equal to 2x, right, like y equals 2x plus 0, right? Our y-intercept is at 0, and the slope is 2, right? So our slope is 2, is 0. So we're going to rise 2 and run 1. Rise 2, run 1. Rise 2, run 1. Or go backwards. So this is what our line looks like. They say, now let's consider shifting the line so that it passes through the point -1, 5, and then use our rules for transformations to write the new equation. All right, so let's just think about our transformations here. We know it's going to move to the point -1, 5. Let's just think about this point at 0, 0, right? If we say this is going to move to the point -1, 5, right? We know we're going to go over 1 and up 1, 2, 3, 4, 5. So I'm trying to highlight it so you can see it there. Right, we're going to move to this point. So we moved left 1 unit, and we moved up 5 units. So we're thinking about like h and k, right? Thinking about h and k. If we were to write this out, thinking about it as like y is equal to, and then we'd say here like our 2 is like our stretch factor, right? Thinking about a times x minus h plus k, right? Yes, this works for lines too. It's not just parabolas and cubics and things. So if we moved to the left 1, right? Think about what would you have in the parentheses with x if you move to the left 1. And I'm going to put my 2 back in, right? That was my stretch factor. That's like my a value. But you know that if we move to the left 1, that would be like saying x plus 1. Okay? And then if we moved up 5, you know our k value would be 5. And this is what we would have right here. Y equals 2 times the quantity of x plus 1, and then plus 5. Okay, so as you think about that now, right, that would be the equation of our line if we moved it over and up there. And you could draw it back in here and see exactly what it looks like. All right, I'm just going to kind of do it as kind of a dash line. All right, this would be like our new line. Okay, so if you're looking at it and trying to figure out, like, hey, what is the equation of that line, right, you can see right here that it has a y-intercept of 7, right? This has a y-intercept of 7, and it has that slope of 2, right? Just like the equation we started with at the beginning, right? Does this all look familiar? The point negative 1, 5 and a slope of 2, right? Y equals 2x plus 7. That is the equation that we're talking about right now. And we would get that if we wanted to simplify this equation that we just came up with using our transformations, right? We would end up with y is equal to, we distribute our 2 through, we'd have 2x plus 2, and then plus 5, we get our 2x plus 7. Right? So it's almost like two ways we can kind of come up with the same equation. But now let's kind of look real quick here at what we were talking about with our point slope form. Okay, so point slope we said was y minus y sub 1 equals m times the quantity of x minus x sub 1. In this case, right, we know our slope is 2, right? We're talking about the exact same problem. And we know that that point we were given was the point negative 1, 5. I want you to think about, let's just take those and let's substitute them into the equation where they would go. Okay, so what we're going to have is y minus, our y coordinate was 5, so it would be a y minus 5 equals our slope, which is 2, times the quantity of x minus negative 1. So if we did minus a negative 1, right, that's going to end up turning into just plus 1. All right, so I want you to kind of look at this right here now versus this right here. Okay, you see how we're kind of getting to the same thing? What's the big difference? Okay, what do you notice there? They both have 2 and x plus 1. And on the bottom one here, we have this minus 5, which, right, on the other one here, right, we have the plus 5. Well, we know that when we move, if we added 5 to the other side there, it would end up being exactly the same as what we have up here. So rather than having to go through all the work here that we would normally do, given a slope and a point, plugging it in to find what our y-intercept would be, if we know our point slope form, we can plug it in here and we'll end up with an equation that looks like this. And if we really want it to go into slope-intercept form, we could go all the way there, right? We could say, you know, our y minus 5 is equal to 2 times the quantity of x plus 1. Well, just simplify it. 2x plus 2 is equal to y minus 5, and we'd add our 5 across there. And if you want your slope-intercept form, that's where you're at. Y equals 2x plus 7. All right, and maybe it hasn't, you know, stuck with you yet. Just hang in there, and let's just look a little bit more here. Okay, so just formally writing it out. I know we already did it on the other page, but hopefully you're starting to be able to do it on your own without even having to watch me write it down, right? Remember, our point slope form is y minus y sub 1 equals m times the quantity of x minus x sub 1. And remember, x sub 1 and y sub 1 come from a point, and m comes from a given slope. Now, where does this come from? Okay, hopefully you're starting to see it here, but if not, it's okay. Here we've got this other formula that you know. M, which is slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, we use this slope formula when we know 2 points, right? When we don't know the slope, right? We don't know what the slope is when we use this formula, but we do normally have 2 points, x sub 1, y sub 1, x sub 2, y sub 2, right? And if we wanted to, kind of think about it here, and actually let me do this. This might even make it click a little more here. I'm going to move this onto the other side, right? That equals our slope. Well, if I wanted to get rid of my fraction, we would multiply both sides times our x sub 2 minus x sub 1, x sub 2 minus x sub 1, and what would be left over would be y sub 2 minus y sub 1, or y minus y, is equal to m times the quantity of x sub 2 minus x sub 1, right? So you see where point slope comes from? It just comes from the slope equation. All we're doing is just changing the things that you know at the beginning and using different variations of the same formula to find the information that we're looking for. Let's jump over here. So sometimes it's just easier to leave it in point slope form. It says find the point slope form of the line that has a slope of 3/5, right? So we have m is equal to 3/5 and passes through the point 10, negative 3. So our x sub 1 comma y sub 1 would be like 10, negative 3. So to write our equation in point slope form, we would just say y minus our y coordinate, so minus negative 3, right? So instead of writing minus negative 3, let's just go ahead and turn that into like plus 3, right? Is equal to 3/5 times the quantity of x minus 10. That is our point slope form. And I just want to emphasize to you, right? Remember, this came from y minus negative 3, right? That's where we got the y plus 3. Let's do the next one. It has a slope of 2.85 and passes through the point 6.1, comma 7.3. So we would say here y minus our y coordinate, 7.3, is equal to 2.85 times the quantity of x minus 6.1. Basically, what we're testing here is, can you read and can you plug things into the right spots? If you can do that, then you can do this. The last one, we want the equation of point slope form that passes through the points 4, 8, and 15, 21. Okay, so this one's a little different, right? Because right now we don't know what our slope is. But we can find that using our slope formula, right? We'll do m should equal y2 minus y1, so 21 minus 8 over 15 minus 4. That's going to give us, what is that? 21 minus 8, 13 over 15 minus 4 would be what, 11? Okay, so we have 13 over 11 is our slope. Now the question is, when we try to write it in point slope form, which point do we use? And actually the reality of it there, it doesn't matter. They will both end up being correct. We could either use y minus 8, right? So I'm using this point first, is equal to 13 elevenths times the quantity of x minus 4. Or we could say y minus 21 is equal to 13 elevenths times the quantity of x minus 15. Okay. If you simplify either of these to slope-intercept form, right, you will get the exact same equation. Okay, so you can use either point. So remember, either point can be used. All right, so it says, what is the relationship between the slopes of parallel lines? Give an example. Okay, so I think we know that parallel lines have the same slopes and different y-intercepts, right? So parallel lines have the same slope, but different y-intercepts. Okay, so if you have an example you'd like to use, I'm just going to write it in slope-intercept form because that's usually what we see here. Y equals, let's say we have the line 3/4 x, and we'll say our y-intercept is -1. Remember, for it to be parallel, right, it's got to have that same slope, but we need a different y-intercept, so we'll just make up a different one. We'll just say +2. Same slope, different y-intercept. Now, thinking back, what was the relationship between slopes of perpendicular lines? Well, hopefully you remember this, but it's probably been a couple years. So you have perpendicular lines, perpendicular slopes, right? I think some teachers say negative reciprocals. Some people say opposite reciprocals, whatever you want to call it there, whatever helps you remember it. So negative reciprocals. So let's say we have y is equal to, let's say, -2/3 x. It doesn't matter what the y-intercept is at this point. Okay, remember, for something to be a negative reciprocal, okay, it has to be the opposite. So our perpendicular line here would be y is equal to, if this one is positive or negative here, our new one needs to be positive, and then we need to take the reciprocal. So this one would be a +3/2x, and you can have whatever you want for the y-intercept. That doesn't matter. Okay, so if I take -2/3, if I take two perpendicular slopes and I multiply them together, I should get -1 as the product. Okay, so perpendicular slopes have a product of -1. And then they say, though, there is a special case of perpendicular lines that do not follow this relationship. And what is it? Okay, well, the only way we could have two perpendicular lines here that don't multiply to give us -1 would be as if we had a vertical line and a horizontal line. So if you think about it, a vertical line could have a slope that would be something like, I don't know, we'll just say 1/0, right? Because it's going to rise but not run. This isn't, remember, this is undefined. We don't really write it that way. And a horizontal line, right, would be something like 0/1. Well, if we multiply those together, we don't get -1. We get 0/0, which, right, isn't going to follow suit with the rest of the perpendiculars. All right, almost done. So using point slope form, find the equation of the line that is parallel to 3x minus y equals 6 and passes through the point -2, 7. All right, so it needs to be parallel to this equation and passes through this point. So what we need to do here is we need to come up with the slope of this line here. And there's different ways to do it. It's in standard form. You could use your -a/b thing, but I'm sure that a lot of us don't remember that. So if you don't, we'll just take it and put it into slope-intercept form, right? So probably easiest way here would be to add y to each side and subtract 6 from each side. So we would get 3x minus 6 is equal to y, so that our slope here we can see is 3, right? So our line needs to have a slope of 3, and it's going to pass through the point -2, 7. So we'll take it here and we'll say, all right, let's use our point slope form. Y minus y sub 1 equals m times the quantity of x minus x sub 1. So y minus 7 will equal 3 times the quantity of x minus -2, which is going to become x plus 2. And that would be our answer. Okay, now, what we could also do here, though, right, say they asked you for, this is point slope. If they asked you for slope-intercept form, you could use point slope, and then to turn it into slope-intercept form, right, just simplify it. Distribute your 3 through, right? You'd have 3x plus 6 is equal to y minus 7. Add the 7 across. And your slope-intercept form would be y equals 3x plus 13. So it's a little bit quicker way. If you're given a point and a slope, try to use the point-slope form. All right, but remember, this is the actual answer for this one here, because they were asking us for point-slope form. I was just extending it a little bit, showing you how you could use it. All right, last one. It says, which of the following is an equation of the line that is perpendicular to 3x plus 4y equals 8 and passes through the point 4, negative 1? Okay, again, so we need to figure out what our slope is going to be from this line. Okay, remember, it's going to be perpendicular to this one. So probably the easiest way, if we don't know standard form very well, is we can take this and we can just get it into slope-intercept form. I'm going to subtract the 3x. So I have negative 3x plus 8. We'll divide it by 4. We get y is equal to negative 3/4 x plus 2. So if our slope in that line is negative 3/4, then we know our perpendicular slope would have to be a positive 4/3. Okay, so if we know that information, along with the fact that we're going through the point 4, negative 1, let's see how we can use that. We're going to say here, y minus y sub 1 equals m times the quantity of x minus x sub 1. Let's plug in what we know. So y minus negative 1 would be like y plus 1. We'd have 4/3 times the quantity of x minus 4. Okay, so that is in point slope form, right? That's point slope form. These ones are all in standard form over here. Okay, so let's simplify this. Let's go to slope-intercept form, and then we can take that and go to standard form. Just go ahead and simplify, right? Distribute your 4/3 through, just like we kind of did on that last slide. Y plus 1 equals 4/3 x minus 16/3. Okay, and even at this point, if you're like, ugh, like what do I do there? I don't like dealing with fractions. Okay, you could still subtract your 1 or 3/3, but if you don't like that, right, let's just take it and multiply each side by 3, get rid of our fractions. So we'd have 3y plus 3 equals 4x, right, because the 3's would cancel, minus 16. And now to get into standard form, let's move let's move our 3y over. So I'm going to recopy it over. I'm going to recopy it up here, sorry. So 3y plus 3 is equal to 4x minus 16. Let's just get our y's over with our x's. And then I'm going to add my 16, so my constant terms are all together. So that zeroes out. That zeroes out. We have 19 is equal to 4x minus 3y. Do we see that one here? I think we do. That would be this one right here. All right, if you have questions, please make sure you mark them down. You can work on the assignment, and I'll gladly answer any questions once I return next week. Or you can send me a remind message there. If you're hung up on something, snap a photo and send it to me, and I'll get back to you as soon as I can.